I hope it is visible now. Let me know if you still want it to be a bigger size. Okay. I hope the font is visible. Great. So as I was saying, these are the comments and this is the lines that we had already discussed. Then coming to the generation of this random data, we are basically concentrating on generation of ones and zeros. So to generate these ones and zeros, we are using the basic function randi. So the syntax for this randi is you will be giving minimum, maximum value, and then the number of rows and the number of columns. So using that syntax, we are generating random data of length 1 cross 8. So basically there is a 1 row and 8 columns. Okay, this is the line that generates random data, random ones and zeros, not random data, random ones and zeros of length 8. Then we are using DISP or disk to display this data on the command window. So if you are not writing this, if you remove this semicolon also, that is fine. So we will also see all these variations. Then we had also seen in the previous class that these two lines basically decides the TB. So bit duration. So the bit duration here I had taken is 10. Okay. And this helps us in simulating the different types of line codes by using the cron function. So whenever you are using the cron function, by having ones of length 10, you can easily generate the final line codes. So we had also seen this, how or why taking ones of 1 comma 10 or 1 comma n bits helps us in generating the line codes in a easier manner. We had also seen this in our previous class. Then this variation, there is a slight variation that I want to mention here. Basically, whatever we are taking here, the bit duration, is useful for non-return to zero line codes. So we can directly use these continuous ones from 1 to 10 for non-return to zero line codes. But when coming to return to zero line codes, you need to bring the pulse width to zero after the half duration. Yes. Normal non-return to zero వచ్చేసరికి ఏమవుతుంది, for the whole TB duration it will be constant. కానీ రిటర్న్ టు జీరోకి వచ్చేసరికి ఏమవుతుంది, ఆఫ్టర్ TB by 2 it needs to come back to 0. So there will be a problem if you take this n bits other than divisible by 2. So what is that problem, we will see. So if at all I am taking it as 10, we already know that it can be divisible by 2. So you can have two equal halves. One half you can have normal pulse and the other half you will be making it to 0. Okay, but when I am having a number which is not divisible by 2, what happens is you cannot make it into two equal halves. Manaku two equal halves raw. Appudu em cheyali ante I will use if condition. Okay, if it is divisible by 2, that means if I am getting the remainder as 0, then what I will do is I will create non-return to zero duration, return to zero duration by taking ones and zeros of equal length. So it is very direct way of taking ones and zeros for return to zero duration. అలా కాకుండా నాకు ఇది డివిజిబుల్ బై టూ అవ్వట్లేదు అనుకో, దాని అర్థం ఏంటి, యూ కెనాట్ మేక్ టూ ఈక్వల్ హాఫ్స్. వెన్ యూ కెనాట్ మేక్ టూ ఈక్వల్ హాఫ్స్, వన్ ఆఫ్ ద పార్ట్ యూ నీడ్ టు గివ్ మోర్ నెంబర్ ఆఫ్ బిట్స్. సో అలా ఇవ్వడానికి ఏం చేశాను అంటే, I had taken else statement and I am using ones from 1 comma floor of n bits by 2. What is the meaning of this floor? So what exactly happens is, let us take the example to understand this. So the example I am taking is, let us assume that there are 11 bits. The TB duration is 11. Okay, what happens when I use floor of 11 by 2? What is the answer for that? Floor of 11 by 2. You can guess. You can give random guess answers. So have you ever heard about this? Okay. H2, you are right. If you are doing 11 by 2, it is 5.5. But I am saying floor of 5.5. So whenever you say floor of 5.5, that means you are taking the floor value. That means ఇంటీజర్ లో ఏదైతే వాల్యూ ఉంటుందో అది యాజ్ ఇట్ ఈస్ గా తీసుకుంటాం. సీలింగ్ అంటే యూ విల్ టేక్ ద అప్పర్ వాల్యూ. ఓకే, సో ద ఆన్సర్ ఈస్ 5. సో వీ విల్ చెక్ దట్. So you can see the answer is 5. So floor meaning ఏంటి అంటే, సో మీ ఇంటీజర్ పార్ట్ ఏదైతే ఉందో అది యాజ్ ఇట్ ఈస్ గా వచ్చేస్తుంది. ఓకే, ఇఫ్ యూ సీ ద సీలింగ్, సో ఫర్ ద సేమ్ థింగ్ ఇఫ్ యూ టేక్ సీలింగ్, సో సీలింగ్ ఆన్సర్ ఏమొస్తుందండి మీ ఎక్స్పెక్టేషన్ ప్రకారం? ఏం రావాలి సీలింగ్? ఎస్, C8 mentions that it should be 6. So you had understood the point. So 11 ని నేను ఈక్వల్ గా డివైడ్ చేయలేను కాబట్టి ఐఎమ్ గివింగ్ 1 డ్యూరేషన్ మోర్ లెంత్ వెన్ కంపేర్ టు అదర్ డ్యూరేషన్. సో రిటర్న్ టు జీరోలో ఏమవుతుంది? ఇట్ విల్ బి స్టేయింగ్ ఫర్ 1 ఫర్ హాఫ్ లెంత్ అండ్ ఇట్ విల్ బి స్టేయింగ్ యాజ్ 0 ఫర్ అనదర్ హాఫ్ లెంత్. సో అదర్ హాఫ్ లెంత్ ని నేను ఇఫ్ ఇట్ ఈస్ నాట్ డివిజిబుల్ బై 2 యూ కెన్ నాట్ మేక్ ఇట్ ఇంటూ 2 ఈక్వల్ హాఫ్స్. అందుకేం చేస్తున్నాను, I am dividing that by using floor and ceiling. Okay, I hope you understood the point. Okay, so floor whenever you use you will get 5 and ceiling whenever you use you will get 6. So that's why we are taking this. So ఇప్పుడు మనం even though it is not divisible by 2 you can create this bit duration return to 0 by using floor and also ceiling. I hope you got the point. Then this is for return to 0. So we are going to generate different types of line codes. The different type of line codes that we are going to generate is, it మనం last time we discussed చేసాం, unipolar NRZ, unipolar RZ, polar NRZ, polar RZ, Manchester. సో ఈ 5 డిఫరెంట్ వేరియేషన్స్ మనం క్రియేట్ చేయాలి. సో ఎన్ఆర్జెడ్కి వచ్చేసరికి వీ కెన్ డైరెక్ట్లీ టేక్ దిస్ బిట్ డ్యూరేషన్, దెర్ ఈస్ నో ప్రాబ్లమ్. ఆర్జెడ్కి వచ్చేసరికి వీ విల్ బి టేకింగ్ దిస్ బిట్ డ్యూరేషన్ ఆర్జెడ్. ఓకే, వెన్ కమింగ్ టు యూనిపోలార్ యూ కెన్ టేక్ ద డేటా డైరెక్ట్లీ, దెర్ ఈస్ నో ప్రాబ్లమ్. ఇక్కడ 1s and 0s ఏవైతే ఉన్నాయో అవి డైరెక్ట్గా తీసుకోవచ్చు. కానీ పోలార్కి వచ్చేసరికి మనం ఏం చేస్తున్నామండి, వీఆర్ మల్టిప్లయింగ్ ఇట్ బై 2 and doing -1. Why we are doing this? Because polar kochesariki you will be having 2 polarities. One is positive and another one is negative. So positive negative rendu ravali ante you will be making your random 0s and 1s into 1 and -1. So whenever you make it as 1 and -1 you can get the polar variation. For polar variation you will be simply using this. Coming to Manchester kochesariki emutundi, for 1 it will be from 1 to 0 and from 0 it will be from 0 to 1. I hope you are getting the point. Endukante మనం we had already seen in the theory. So what we will be doing is first we will represent our data as this. That means you will represent your 0s and 1s. You will represent your 0s and 1s as -1 and 1. First you need to represent your data as -1 and 1, and also along with this you need to have your duration, that is whatever the duration that we are creating using 1s and 0s, that should also be represented as 1 and -1, because you require this variation of 1 and -1. So whenever you require such a variation, మన duration field nu kuda you will be representing this as 1 and -1. So adi ఏ duration field ni represent cheyali, RZ, because for Manchester half the period it will be 1 and half the period it will be 0. So that's why we are using bit duration RZ. So దీన్ని యూస్ చేసి we will be generating the bit duration for Manchester. So bit duration Manchester is equals to bit duration RZ into 2 -1. So I hope you understood why we are taking this bit duration RZ. Okay, so once this is created, transistor duration using this formula. So you require two variations. Okay, you require two variations, one for data, and another one is for duration. So ఈ రెండు యూస్ చేసి we will be generating the data for Manchester. Okay, once you had done all these things, so now see the MATLAB window. So for unipolar NRZ, what you can do is you just use the function cron. This we had already discussed in the last class. So unipolar NRZ, you use cron, data comma bit duration. Okay, data is of zeros and ones, and bit duration is of length. What is the bit duration length we had taken? What is the bit duration length that we had taken? 10. Okay, so you will get 10. So that's why in the program we had taken cron with the normal data and normal bit duration. So there is no variation for generating unipolar NRZ. But coming to polar NRZ, as I was saying, please see the MATLAB window. You need to take the data as ones and minus one, because after getting ones and minus one, you can use this cron function to generate the data as 1 minus 1. So first you need to make the data feasible for generating polar non-return to 0. Okay, so that can be done by doing this data star to minus 1. So whenever you do that, your 101 will be converted to 1 minus 1 1. So once this is obtained, you can use cron. Okay, since it is non-return to 0, you can use the bit duration as it is. So there is no need of any variation in this bit duration as it is. So cron bit duration, what will happen? This one will be represented as 10 ones, and this minus 1 will be represented as 10 minus 1. So cron function enti ante, it will generate a output depending upon this second part. So cron lo vachesariki there are two parts, cron of part 1, or you can say variable 1 or parameter 1, and another parameter is part 2. So whenever you use this cron function, మనకి ఏమవుతుంది అంటే part 1 అనేది ఈ part 2 తో మల్టిప్లై అవుతుంది, and it will be generating for the whole duration of this part 2. Okay, so since మన bit duration values ఏంటి, all are ones. Okay, all are ones, and what is the duration of this bit duration? That is of 10. So for 10 length, you will be multiplying this ones with the first element. So 1 with 1, you will get this. Then again 1 with 1. Ala 10 times multiply ayi aa value ikkada present avutundi. Okay, similarly minus 1 kuda ante. So ila generate cheyadam valla manaki advantage enti, you can, whenever you plot such a data, you will get ones for length 10. Okay, and minus ones for another length 10. Then again ones. So you can plot your polar NRZ by using this cron and this data. I hope you got the point. So this is how you are going to generate the polar non-return to 0. Then coming to return to 0, we had already discussed that you require a change in the bit duration, because in the previous case, what is happening is this bit duration is fixed, or you need to have the pulse constant for the whole TB duration. But return to 0 వచ్చేసరికి ఏమవుతుంది, after TB by 2 it should come back to 0. So ఇలా రావడానికి మనం ఏం చేస్తున్నాం, for to get this type of thing, what we are doing is we are taking bit duration RZ. So bit duration RZ ni మనం already పైన fix చేసాం. So it will be having ones from 1 to 5 and zeros from 1 to 5. So you will be taking such a bit duration and you will multiply this with this data. Okay, so that's how you are getting this unipolar RZ. Then similarly, you can do it for polar RZ. Okay. Then finally, Manchester is done with the help of data that is generated suitable for Manchester and also the bit duration that is generated suitable for Manchester. Fine. Finally, you will plot them. So ఇక్కడ నేను ఎన్ని గ్రాఫ్స్ డిస్ప్లే చేస్తున్నాను? 2 graphs I want to display. So what are the 2 graphs I want to display? One is unipolar non-return to 0 and another one is polar non-return to 0. So 2 1 1 means 2 rows 1 column, and I am taking the first figure or first sub figure. 2 1 2 means 2 rows 1 column, second sub figure. And these are the 2 functions that we will be using to restrict the axis and title. So if at all you want to give the title, you can use title function to give the title, and if at all you want to use to restrict the axis. So whenever you are plotting, the problem is manaku original figure to party, there will be some extra space that is coming in the left, right, and also top and bottom. So what అన్నిటిని మీరు restrict చేయాలి అంటే మీ యాక్సిస్ ని మీరు కంట్రోల్ చేయాలి అనుకుంటే you can use this axis function, and these are the parameters that you can give. So the parameters here are something like this. This gives me the left justification, right justification. This is bottom and this is top. So me axis, okay, I will explain it using this. So why we are starting with 0, we already know. So ఏదైతే లైన్ కోడ్ ఉందో మనం 0 నుంచి స్టార్ట్ చేస్తున్నాం, and at max it can go up to length of unipolar non-return to 0. Then unipolar non-return to 0 minimum value ఏదైతే ఉందో దాన్ని తీసుకున్నాం. -1 ఎందుకు చేసామంటే అక్కడి నుంచి మనం -1 వాల్యూ వరకు డిస్ప్లే చేయాలి, అండ్ మ్యాక్స్ ఆఫ్ యూనిపోలార్ +1 అంటే అక్కడి నుంచి +1 వరకు డిస్ప్లే చేయాలి. We will see all this. Okay. Then we are also displaying return to 0, both unipolar and polar. Finally, we end up with Manchester. So Manchester kochesariki I had used figure. Not only for this, ikkada kuda. So basically నేను ఏం చేస్తున్నాను అంటే I am using both the variations, figure and subplot. So ఈ ఫస్ట్ subplot రాసినప్పుడు ఏమవుతుందంటే I will get a plot with 2 sub figures. Then I use figure. So whenever I use figure, I will get a separate window. A separate window lo I will get return to 0 of polar and unipolar. Then again I am using figure. That means I will get one more window. అందులోకి వచ్చేసరికి నాకు Manchester display. So basically ఇక్కడ నేను ఏం చేస్తున్నాను అంటే I am displaying 3 windows. Okay, and 3 windows will have 3 different figures. So we will see how this output comes. I hope you got the point. Okay. So to run this, I had already explained that you press this run button. So please see the MATLAB window. As of now, you can skip seeing the XAMPP. So I had pressed run button. So whenever this is popped up, you just press on change folder. So you can see here some busy line is coming at the bottom left. That means it is doing some processing. So this is the random data that is generated. So 2 1s, 0 2 1s, 2 zeros, and 1. This is the data that is generated. Now for this data, it will plot. I hope you are okay. I hope you are able to see the graph regarding unipolar non-return to 0 and polar non-return to 0. So this is how it is displayed. So as we are able to see, the data is 110, 110, and 10. I hope that is the data. Let me cross check the data. Yes, 110, 110, and 10. So this is the data. I think, okay, there is a slight change in the data because I had pressed the run button twice. So it has run it twice, and the previous data was overlapped or erased because of the new data. Okay, are you able to see the window now? Unipolar non-return to zero and polar non-return to zero. Fine. Why only few students are mentioning? Presenting the other two windows also. One is return to zero part. Okay. And the other one is I hope you are able to see the variation between non-return to zero and return to zero, because in non-return to zero, the pulse is staying in the same value for the whole bit duration. But coming to return to zero, for half duration, it will be staying as 1, and for other half duration, it will be 0. For 0, it will be completely 0. Okay. Then Manchester. So you can see whenever I use figure, it becomes very cumbersome because it has generated 3 separate windows, and I was forced to open, or I was forced to show you 3 different windows. So in the next thing, what we will do is we will club all these windows into a single window. So for that, we will be using subplot. Okay. So I hope you are able to see the Manchester. So for the same data, this is how the Manchester looks like. Okay. Now tell me what should be the subplot values to show all these 5 plots in a single window. So I am changing the subplot values from 211 to 511. Then this becomes 512. There is no need of figure now because we are trying to plot everything in a single window. Okay. This becomes 513, 514. So I will be generating one more random data. So for that random data, I will be showing you how it looks like when you use a single window to plot all the plots. I hope you are able to see the window. Okay, please wait, I will share it. So this is how it looks like. So whenever you use subplot, and as F3 was saying, you need to use something like 511, 512, 513, and 514, 515. Then you will get the figure something like this. Okay. So the first one is for unipolar non-return to zero, then polar non-return to zero, then comes unipolar return to zero, polar return to zero, and the final Manchester. So you can compare all the line codes within the same window. Okay. So